Science A, Unit 1, Primitive Types, Lesson 2, User Input and Variables. The objectives of this lesson are for you to be able to write programs which use user input, know how to declare a variable, and use it to store values, and to gain some understanding of what happens when a variable is declared, to use string concatenation to create strings from multiple parts. Let's begin. Scanner allows us to take user input and incorporate it into our programs. We have two mysterious lines we must put into our program. We'll always format our scanner like this, and we'll discuss later how this works in more detail. For now, just accept it. There will be things that will get explained later, but it's going to take away from the lesson if we constantly explain every little nuance. There are some things that I'll ask you to accept for now and will explain in greater detail later. So we have import java.util.scanner. Accept it. That's how you get your program to know you're going to use scanner. Public class demo. Demo is the name of my class. Public static void main. That's my main method. Then the line that we're going to have says scanner scan is set to new scanner system.in. Accept this. This is how we tell the computer that anytime we talk about scan, we want it to use the system input, which is the keyboard. Okay? When we use a scanner to take input, we usually read a string from the keyboard is system.in, and store it as a variable. Okay? Now, we can think of variables as containers in memory. Those of you that took computer science principles, I talked about variables were like baggies. Okay? You name the baggie, and then inside the baggie is something, a value. When we declare a variable, we tell the computer to allocate some space in memory for something. We tell it to go grab a baggie and name it so that we can put something in it. We tell it what the name of the thing will be so it knows how to find it later. I want this bag or that bag. And what type of thing will be so that it knows how much space to set aside. Think about Christmas. You want to wrap a sweater? Okay, you need a certain size box. You want to wrap a bicycle? You might just need a great big bag. Okay? Different kinds of data require different amounts of storage. So we tell it what the name of the box is going to be, or the bag, and we tell it how big or how much memory we need based on the type. String n. This tells the computer to allocate space for a string and call that space n. Variables can change in programming as they are just containers. Now the name of the container doesn't change. I still have baggie, still have n, but what's n in can change. I can take things out of it and put things in. Think of the variable as a baggie or a box into which you will place a value. When we first put a value in the container, we initialize the variable. Later, we can change the variable so it contains a different value. To either initialize or change the value of a variable, we use the assignment operator, which is just the equal sign that you've learned in math. But the equal sign does not represent equals in programming. It's a sign. The variable on the left of the equals sign is set to the value on the right of the equal sign. So here, if you look at these two lines of code, I have n is set to scan.nextLine. Variable n now contains whatever the user types. N is set to John. The variable now contains John. So here's my variable, my little baggie D. It's out here in memory. It's called n. And I refer to n, but n contains different things, either from this first line with the user types, or the second line reassigns what's inside of n to be the word John or the string John. When we want to print strings out, we can combine literal strings. things in quotation marks and variables. For example, system.out.println, hello, space, end quote, plus n, plus, quote, how, space, how are you, end quote. Now, what you need to notice, this add sign is not adding, it's concatenating. What will that print statement do? In the statement above, hello is a literal string and n is a string variable. When we glue them together using a plus sign, it's called concatenation. Concatenation. If there were no variable name in n, if there were no variable named n in memory, then it would cause an error, okay, when we tried to compile it. When we tried to say, hey, computer, here's my program that I can read and understand. I want you to compile it. Basically, compiling is asking the computer to take it and translate it from human, from Java, something humans can read, to machine language, ones and zeros, binary. So if there were no variable called n, the computer would say, okay, I know how to print out hello, I know how to print out how are you. I don't know what n is. You don't have double quotes around it, so it's not a string. You're telling me it's a variable, but you don't have a variable called n. You'll get a compile error. There are also some rules about variable names, also called identifiers. An identifier can only be letters, digits, underscores, and dollar signs. So while the dollar sign is a special character, you cannot use a hashtag or the @ symbol or an exclamation point, just the dollar sign or the underscore. An identifier cannot start with a digit. An identifier cannot be a reserved word. An identifier cannot be called false, true, or null. Those are Boolean values that we will hear about and talk about later. An identifier can have any length. So you are not limited. Now, that said, remember, if you're going to use this identifier later in the program, you don't want it so long that it's difficult to type in, takes up too much time. And the longer the identifier, the more chances there are for typos. That said, you also want to make it long enough and clear enough so somebody knows what information is contained in that variable. Now remember that identifiers are case sensitive. So area, area, and area, all lowercase, capitalize the first letter and capitalize the whole word, are 3 different identifiers. This is the end of lesson 2. You may now continue on to lesson 3.